Welcome back. In this tutorial, we will build secure JWT authentication for a Python banking API using Flask, SQLite, and Postman. We will create a public health check and login route. Then we will protect the current user, account, and transaction listings. Finally, we will add an administrator-only user endpoint. Start inside the project folder. Create a Python virtual environment, activate it, and install the packages from requirements.txt. Copy the example environment file so the application can read its local configuration. These commands keep the tutorial dependencies isolated from other Python projects. The project uses Flask for the web API, Flask JWT-Extended for access token authentication, and Python.env for environment variables. Pinning the versions makes the setup repeatable on another computer. In the environment file, define a long JWT secret, a 30-minute token lifetime, and the SQLite database path. Never commit a real production secret to Git. Now import the standard SQLite, date, decimal, and path. Utilities. From Flask, import the application, request, response, and database context helpers. From Flask JWT-Extended, import the JWT manager, token creator, identity reader, and protected route decorator. Werkzeug provides secure password hashing and verification. The users table stores a unique username, a password, hash, a full name, and a role. The password itself is never saved. The role is limited to customer or admin, which gives us a simple foundation for role-based authorization. SQLite also records when each user was created. Next, create the accounts and transactions tables. Every account belongs to one user through owner ID. Every transaction belongs to one account. Amounts and balances are stored as integer sends to. Avoid floating point money errors. Foreign keys preserve the relationship between users, accounts, and their transaction history. The Get Database helper opens one SQLite connection for the active Flask request. Row factory lets us access columns by name, and foreign key enforcement is enabled immediately. The close helper removes and closes the connection when the request context finishes. For this local demonstration, see 2 customer users and 1 administrator. Each password is passed through generate password. Hash before insertion. Parameterized SQL keeps values separate from the query. The seed data is educational only, so replace every demo credential before using this design elsewhere. This is the essential password security flow. Registration or seeding stores only the generated hash. Login uses check password hash to compare the submitted password safely. We never decrypt or return a stored password. Inside Create App, load the environment and configure the database location, JWT secret, token expiration, and JSON behavior. Initialize the JWT manager with the Flask application. Register the database cleanup function, then create and seed the database inside an application context. Test configuration can override these values without changing production settings. The health route is public and returns status OK. With HTTP 200, monitoring tools can call it without authentication. The root gives a short overview of the API and tells clients that protected requests use a bearer JWT. The login route reads JSON safely, trims the username, and validates that both fields are present. It queries the user with a parameterized statement. If the username does not exist, or the password hash does not match, the root returns the same. Generic invalid credentials response. This avoids revealing which usernames are registered. After successful verification, create an access token with the user ID as its identity. Add the role as a claim for future authorization. Rules. The response contains the token, bearer type, expiration time, and safe user profile fields. It never contains the password hash. The JWT identity contains the authenticated user ID. We convert it to an integer and load the current record from SQLite. The API me route uses the JWT required decorator, so Flask rejects missing, malformed, or expired tokens before the route returns the user profile. The account endpoint is also protected. Administrators keep the base query and can see all accounts. For a customer, the server adds a condition where owner ID equals the authenticated user ID. This authorization happens in the database query, ensuring Rainy cannot request SOCA's accounts by changing the client. The transaction endpoint supports a result limit and an optional account number filter. First, validate that the limit is between 1 and 100. Customer requests automatically receive an owner condition. Then combine that condition with the optional account filter. Order the newest transactions first and bind every value as a SQL parameter. The administrator route begins with the same JWT protection and user lookup. It then checks the stored role. A customer receives HTTP 403 with a clear forbidden message. Only an administrator can query and return the complete user list, and the serialized response excludes every password hash. The code is ready to run. Start the development server with Python app.py. Flask initializes the SQLite database and listens on localhost port 5000. This development server is suitable for the tutorial, but not for a public production deployment. Before testing the endpoints, inspect the SQLite database. The users table contains password hashes instead of plain passwords. The accounts table links each account to its owner. The transactions table contains deposits and withdrawals linked to account IDs. These relationships are what our authorization queries protect. Open the Postman collection and send the public health check request. It calls get API health without a token. The server responds with HTTP 200 and status OK, confirming that Flask is running and Postman is using the correct base URL. Now test the failure path deliberately. Send Rainy's username with an incorrect password. The API responds with HTTP 401 and invalid credentials error and a generic message. No token is created and the response does not confirm whether the username exists. Send the same login request again with the correct demonstration password. This time the server returns HTTP 200, assigned access token, bearer token type, and 1800 second lifetime and Rainy's customer profile. Postman stores the token for the protected requests that follow. Call get API me with the token in the authorization header. The header starts with bearer followed by The JWT. The server validates the signature and expiration, reads the identity, and returns Rainey's current user record with the customer role. Next, call get API accounts with the same customer. Token. The response scope is own accounts and contains only Rainey's everyday and savings accounts. Soka's account is excluded by the server-side owner condition, even though all accounts use the same SQLite database. Call the protected transaction listing and pass a limit. In the query string, the response contains only transactions. For Rainey's authorized accounts, each item includes its reference, account number, deposit or withdrawal type, formatted amount, currency, description, and creation time. To prove authentication is enforced, send the account request. Without an authorization header, Flask JWT-Extended stops the request and returns HTTP 401 because the access token is missing. Protected data is never queried for this request. Authentication alone does not grant every permission. Send the administrator user request with Rainey's valid customer. Token. The token is accepted, but the role check returns HTTP 403 because administrator permission is required. Log in again using the local administrator demonstration account. The credentials pass the same secure verification process, but this user has the admin role. The returned JWT now represents the administrator identity and is stored for the final protected request. Use the administrator token to call get API admin. Users. The server returns HTTP 200 and all. 3 safe user profiles. Password hashes are still excluded. This confirms the difference between authentication, which identifies a user, and authorization, which controls what that user may access. Automated tests protect the behavior we just demonstrated. They verify the health check, successful login, invalid password, rejection, missing token rejection, customer data isolation, customer forbidden access, and administrator access. Run the complete unit test suite from the terminal. Every one of the 7 tests passes. These tests use a temporary SQLite database and a separate JWT secret, keeping test data isolated from the local tutorial database. Before deployment, replace the JWT secret, use HTTPS access tokens short-lived, and add refresh token revocation when the application needs it. Most importantly, validate authorization for every protected resource on the server, not only in the user interface. The JWT Banking API is complete. You now have secure login, protected account and transaction, requests, customer isolation, administrator authorization, and automated coverage.